All right, so this is DataLab2. Our job today is to start working with daily diary data. In the first day lab, at the end of it, I suggested placing the data on PennBox. And so the data I'm working with are on PennBox. And I have box sync enabled, which allows me to access the data on PennBox pretty easily. So we're going to go through this script. This script is basically a list of commands that will help us describe the daily diary data. This script is available to you on Canvas. And so if you double click on the script, it should open up in RStudio after you've installed RStudio, or you can right click on it and open up in RStudio, and it will appear like this. Most of this you won't need to change. It's a list of commands that you're telling OR to do that will generate some output. But there are a couple of things that you will need to change in order for it to work on your computer. The first thing is letting OR know where the data are. So that's what this setting your work directory command is doing. For me, it's in users, dsta, boxsync, and the Comm843 folder. So the easiest way to get this is if you right-click on the data file that you're working with, if it's on PennBox or if you're using some other type of Dropbox, and you can usually do something like get info, and it will have this string that you can just type in. And so when I run this, I'm basically telling OR where the data are. By the way, these green things are comments that I'm making. So if you want to make a comment in OR, you just do this hashtag. I'm showing my millennial nature by calling it a hashtag. It's not, it's a pound sign, I guess. And you can then type, and now OR isn't going to do anything with this. It's not going to, it knows that it's a command, and it's not going to try and run a function or anything. So it's just useful for annotating your code, which I suggest you do a lot. Okay. The other thing you want to do now that OR knows where the data are is you want to load the packages that you're going to use throughout the script. So packages are just bunches of functions that other people who are a lot more talented than I am have made, and that are available for use for everyone. And the way you call these packages is with this function here, so the library and then the name of the package. So I'm calling the psych package. This is useful for describing data, and the ggplot2 package, which is really fun for plotting data. You might get an error if you try to run this and the package isn't installed. If that's the case, you can just comment this line of code and run it. And you just, it's installed our packages, and then you put the package that you're trying to install in between these comment bracket things. Okay, so OR knows where my data are, and I have loaded the packages that I'm going to use, and now I'm going to import the data. These are .csv files, and so I'm using the read.csv command. I'm reading in this data file, so this is the name of the data file. The nice thing about RStudio is that if you, it will autocomplete for you, so if you don't remember off the top of your head the exact wording or exact name of the data set, you can type a little bit, and then if you press the tab key, it will autocomplete, which is convenient. So you want to read this data file, and you're going to read it into OR, and you're going to call the data set daily diary. You can call it whatever you want. I think daily diary just makes sense. And you can see in my data part of RStudio that I now have a data set called data diary. It has 1,638 observations, basically rows of data for 59 variables, so 59 columns. So you can click on this to look at the data. I always like to look at my data, and you'll see kind of some key variables. One is an ID variable. And the first thing you'll notice is that this data set is in a long format. This is what we would call a long format data set, where each row is 1 day for each participant. So the evening variable tells you what day of the study it is. Remember, this is a daily diary study, so they're doing end of day reports. And it's going from day 1, 2, 3, all the way to 21 for each person. And so when we get to 21 days for person 101, we then get to the next person. So every person's data is in the data set, and every row in the data set is 1 day for one participant. In the codebook, you will be able to see what these variables correspond to, but some of them are pretty obvious. So this is ask them how happy they were that day, how sad they were that day, how anxious. I use the _e just to remind myself that these data come from the end of day or evening reports. And that's not an issue right now when we're just working with the daily diary data. But because we've measured happiness and sadness at the momentary level in the experience sampling data, when we merge those two data sets, if we ever do that, we'll want to be able to easily tell which variable comes from the daily diary and which variable comes from the experience sampling. So you can just kind of look through, it's kind of fun. I don't know, I think it's fun you can even kind of eyeball how things are changing from day to day for each person. And you'll notice there are different types of variables. There are some that are clearly like binary, 0, 1. There are others that are more continuous, right? Going from, I think, 1 to 100 or 0 to 100. You can scroll all the way right, but it's not giving you all the variables that are in the data set. So to do this, you can just go up to this arrow over here, click it, and then it will let you go all the way to the end. So the last day, it has the date that the study was, the date that the evening diary was completed. And then it also tells you the day of week over here, which is kind of useful. All right. So, you don't want to rely on just looking at your data because there are so many rows. You're not going to be able to like eyeball any mistakes that are happening. I should say before I go any further, you'll notice that there are NAs in a lot of places. NA stands for missing data in R. And you'll notice that for lots of days in this first person, 101, they really only have like 5 days where they actually completed the diary. And you could get rid of the days where they didn't complete the diary, but I like to keep all of the days. And just so here you have all 21 evenings, even though evening 3, 4, 5, 6, 7 are all NAs across the board. I like to keep that in there because there are some instances where you will do lagging. So you might ask a question about how does my, I don't know, happiness today predict my sadness tomorrow? And so you're going to move some of these values up and down rows in order to get the timing right so that you can ask about how things are today based on yesterday. And if you don't have these rows of NAs, it's going to skip. Like in this case, it would skip from day 2 to day 8. So I just like to keep these NAs in here because I often do lagging stuff. And this will just kind of work all of that out for me, and I don't have to worry that I'm skipping over days when I do lagging. That's something more advanced that we'll talk about later, but just in case you're wondering like why have these NAs in there at all, that's the reason for that. Okay. Oh, look, and I have like other data sets open right now. It's probably not good. All right. So you don't want to just rely on eyeballing your data. You can use commands to get a sense to describe the data in a kind of more systematic way. Here are some useful commands. The head command, so head and then the name of your data set, gives you the first couple of rows of your data set. So here it's the first 6 rows, and you can just kind of double check that all your variables are in there and everything makes sense. You might want to see the first 10, so then you can just specify that I want the first 10 rows of the data set. And you can also do it from the bottom up. So tail is like the end of your data set rather than the start of the data set. So you'll notice that the ID is 191 instead of 101, and it's their very last day up to day 16. Okay. So one question right off the bat we might have is how many unique participants do we have in our data set? And to do this, we're just going to check how many unique ID variables there are. So we have our data set, and then this like $ thing is basically like I want to look at a specific column in my data set. In this instance, I want to look at the ID variable. I want to see how many unique ID variables there are in the data set. This also auto-completes, which can be really convenient. So for example, if I put in I, it will bring up all variables in the data set that start with the letter I. And so if, for example, you forgot what your ID variable was called, or if it was lowercase or uppercase, this is a useful way to find it. Okay, so I'm going to run that, and the answer is 78. So there's 78 unique participants in this data set. One thing I like to do when I run functions and I'm going through a data set for the first time, or anytime I do it, honestly, is it outputs the result here, but this isn't going to hang around in my next session. So I usually like to kind of paste it underneath the command and then comment it out. So then the next time I open up this data set, I find the answers to what I'm looking for. Okay, so there's 78 people in the data set. Do they all have their 21 days? Yes, they do, right? And this is not letting us know if they have completed all 21 days. It's just letting me know that everyone has 21 days, and this is useful for the lagging type stuff that I talked about earlier. Okay, and now we're going to get some basic descriptors for the whole data set. So we're going to describe the entire data set. And when we do that, it gives us some useful information, such as the number of entries, the mean value, the standard deviation, the median, the min-max values of all of our variables in the data set. So this is just a kind of very nice first kind of way of looking at your data set. It's rough, but it's useful. The things that I look for are, okay, if I look at the number of evenings, is the min 1, is the max 21? If there are values beyond this, that doesn't make any sense because this is a 21-day study. I might want to look at the min and max values of my happiness variable. That was, people were able to report happiness of 1 to 100. So if there are values beyond this, then that's problematic, and I would have to go chasing the raw data to see what was happening. Yeah, so it's like a nice way to just kind of get a sense of whether your data look the way they should based on the code book and how you structured your protocol. The mean values and standard deviations are kind of useful. Like sometimes I report these in the method sections to be like, on the average day, happiness was 70 with a standard deviation of 21. It's not describing any individual, it's just describing the mean happiness for all of the days that you have available to you. One thing you'll notice is that there are 1,638 rows for ID and evening, but there are fewer rows for some of the variables. So there's only 1,314 for happiness, sadness, etc. And this is indicating that there's missing data. Even though all of the IDs and days that should be in the data set are there, there are instances where a person didn't complete their evening report, which happens, right? You're asking a lot for participants, but just giving you, that's where you find that information is what I'm trying to say. Okay, so that's kind of looking at the whole data set. Sometimes you don't want all of this information, or you want to start focusing in on variables that you care about. And so at this point, I'm going to start focusing on the variables of happiness and curiosity. So as you are making your way through this data lab, you can switch out these variables. I encourage you to switch out these variables with other variables so that you get some practice doing that. So for example, you could go after sadness instead of happiness. But I'm going to go with happiness. And I'm going to use the describe function, but now instead of doing describe on the whole data set, I'm doing it on the happiness variable within the daily diary data set. And I get this, which I've already pasted from before because I'm prepared. So we have 1,314 entries of the happiness variable. The mean is 70.06. This is a standard deviation. This is the min and the max value. Great. That makes me happy. The curiosity scale is made up of 2 items, one that has to do with stretching, the other that has to do with embracing. For the purposes of this data lab, it's not important what exactly those tap onto, but the important part is that usually these are combined into one variable. So I'm going to look at them separately just to make sure that the min and the max make sense, get a sense of the means and the standard deviations. So I'll do that for the stretching. I'll do that for the embracing. That's cool. And now I'm going to create a new variable called curiosity average. And so it's the average of these two curiosity items. So I'm going to make that variable, and that variable is going to be the mean of stretching and embracing, these two variables. This na.rm tells OR how to deal with missing data. It's not going to be an issue for us because both items have the same number of entries. But you can check out this link for a bit more information about how OR can treat missing data when you're doing things like taking the mean of two items. All right, so I'm just going to do that. And then I'm neurotic, and whenever I run anything, I like to look at my data to make sure that it actually did what I thought it was going to do. So I'm going to open up my data set. I'm going to scroll to the end, because when you created a variable, it's going to end up at the end of your data set. And I can see that I have my new curiosity variable, and it's one value. It's the mean of the two, the stretching and the embracing components. And it looks beautiful. Great. All right. And then you could also, use your describe function and just get a sense of the average curiosity variable. So I'm going to describe it, and I'm going to paste that in there so that I have it for later. Okay. Now, one thing we might want to know is how many days of data do we have to work with if we're going to focus our analyses on curiosity. So how many days of like complete days where participants have values for the curiosity variable exist in our data set. There are lots of ways to do this. This is probably not the slickest way of doing things, but I'm definitely not the slickest coder, but anything I do works. So what we're going to do is we're going to subset to a data set that has actual values, so it doesn't have any missing values for the new curiosity variable. So we're going to call this new data set daily diary no NAs. This is a terrible name, but it tells me what it's doing. And so I'm going to subset this daily diary variable so that it only has complete cases for the curiosity variable that I just created. So when I do that, you'll see that a new data set is created up here. It has fewer rows, and it has a number of rows that correspond to the number of actual rows where there's a value for this curiosity variable. And so if we open that up, you can see that now it goes from evening 1, 2, 8, 9, 10, 1, 2, 3, 4, 5, or it doesn't have 5, right? So it's skipping the rows that have missing data in our larger data set. And if we go all the way to the end, we'll be able to see that there are no NAs for curiosity, right? It's all values. Great. And now we can, now that each row is a row of actual data, we can count the number of rows per participant. So we're going to create a variable called count, which is literally us counting through the number of rows. So you want to run this, and if you open up your data set, you will see what it's doing. So it's going 1, 2, 3, 4, 5, and then they've encountered a new ID variable. So they're starting from 1, 1, 2, 3, 4, 5. This person had 17, and it starts again. You don't have to eyeball that and count, the largest number that's available for each participant. You can ask OR to do this for you, where you're basically saying, like, looking at this count variable for each participant ID, tell me what the max number is. And you can create a new data set. I don't really, because this is going to overwrite your count, the data set that you just added count to, but I'm not planning on using this data set going forward. So I just put it in here, and you'll notice that now we only have 2 variables. And we only have 78 observations, which corresponds to the number of participants in our sample. So we have the unique IDs in the data set, and this is the max number of days that they completed. Okay, so this is useful information. We can describe this count variable, and we can see that the average numbers of days completed was about 16 or 17. Some participants completed as few as 3 days, and there were participants who completed all 21 days for this curiosity variable. A table might be a nicer way to view this. So we're going to make a table of this count variable. And now the top of the table is showing you the number of days, going from 3, which was the lowest number of days completed, up to the max of 21. And it's telling you how many participants fell into each of these categories. It can be useful to plot this information. And so we're going to use ggplot to do that. ggplot is the kind of thing that I usually get code that's online, and then I play around with it, and eventually it makes sense, and I know what parts of the code to change to do what I want to do. So like my suggestion would be to just play around with it. If things don't make sense straight away, Google it, and there's a ton of resources for ggplot and how to make things pretty. But we're going to get started here, where we are going to use ggplot. The data we're using is the data that has information about the max number of days per person. Our x-axis is going to be the max number of days, so the count of days. And we're going to make a histogram of this. This just has to do with the colors. And then we're going to label the x-axis so it tells us the number of daily diary days completed. And we end up with a nice histogram that tells us the number of days completed on the x-axis and the number of people who have these values. So there's like a decent amount of people who completed 21 days. It's like 20 people. So that makes me happy. And just kind of, you can also feel free to play around with this. If you want to make the color of the lines red for some reason, you can do that, right? If you want to make the fill blue, you can also do that. And it's horrifying to the eyes, but it's fun. And so that's just a useful kind of plot to get a sense of, all right, how many actual days do I have to work with, and what are the differences between participants and how many days they actually completed. Okay, so now I want information not so much about aggregated happiness or curiosity for the entire sample. I want to know about dynamics. This is a class about time, after all. So I'm going to plot intra-individual change in the curiosity variable. So again, I'm using ggplot, using the big data set now, the long data set with all the observations. A row for each evening for each participant. On the x-axis, I'm going to want to have time in the study, which is day in the study, or here I'm calling it evening. And I am just indicating to OR that there are groups of people in here. So there's different participants in here. And the way that OR identifies that is by looking for different IDs. And I want OR to give a different color to each ID. So that's what the color factor thing is doing. Oh yeah, if I didn't have this code in here, I'll run it so you can see it. So you can see the reason I have colors equal none in it. And then I'm saying I want you to draw a line that shows me how curiosity is changing across time for each ID. So let's run this. And it should pop up here. There. So this looks horrible, and part of that is because it's telling us which color is associated with which ID. This isn't super useful information right now, and it's just detracting from the main info that I care about. So I'm going to kind of put that back in. So I'm getting rid of the comment I made earlier, and now I'm telling it I don't want any of these guides. Make sure that these guides are none. And now it looks like this. So this looks like a bowl of spaghetti, but I actually find this kind of useful to look at as a first step to getting to know my data. It gives me some sense of individual differences. So I can see, this person's kind of hanging out over here. I can see there are a couple of people whose curiosity is at 0, and it's not fluctuating that much for most of the time. But I also see that there's a decent use of the range of the curiosity going from low to high. So there's no places where I'm like, there are huge gaps or anything, which is kind of useful to know. And then again, the x-axis is going from evening 1 to 21. So it's kind of cool to look at this. It does give you a sense of just how much variability from day to day there is in something like curiosity. It's also useful to notice the missing data. So you can see that this person it looks like they're starting from nowhere, but that's because they had missing data here. And I like to have that information in just because it represents the data. I don't want to say truthfully, but I don't think that's the right word. Okay. Maybe you also want to plot dots for each day. So here you kind of have to do some work to be like, oh, wait, is it evening 5? Is it evening 10 or whatever? You can get or to do that. And so we're adding a new line. The new line is g_on_point. So I'm saying I want a point for each instance of the curiosity variable, and you can just make it black. And it looks horrible. So you don't want to do this, but you can see why in some instances it might be useful. Like it tells you exactly where the value is stopping at each day. Okay. I'm not a big fan of the x-axis because it's hard for me to distinguish that this is day 1, 2, 3, 4. I can tell 5, 10, 15, 20, but I want to know all of the days. So I'm going to go back to my plot that doesn't have the points in it. So I'm just copying the code from above. And now I have an extra line that gives instructions about what to do with the x-axis. So I want breaks at every single day. So I'm doing 1, 2, 3, 4, 5, 6, 7. And I find the name evening kind of confusing. And so in the plot, I just want to say call it day. Like on day 1, what was your curiosity look like? And when we do that, it looks like this. So now I can easily see, okay, day 1, day 2, day 3, et cetera, et cetera. Okay. The default background is this really ugly gray that I don't like. And so in the next step, I'm going to get rid of that. There are different themes for ggplots. And one that I like is a theme _ BW. I think that stands for black and white. And so when you add that to this bit of code, it ends up looking a little bit prettier. So now it's like white instead of the grayish grid. All right. Okay, so this is kind of a fun thing to look at. It's a good first step, but it's not the most useful for actually getting a sense of what's happening to each individual. So there are instances where you might want to look at just one individual's data and how it's changing from day to day. So in the next part of our code, we're going to take one person. And it'd be nice to have someone who completed all 21 days so that we can get a good sense of how things change from day to day across the entire period. So I'm creating a new data set, calling it full completion, and I'm telling OR to look at the data set where I have information about how many days each participant completed. So just as a reminder, this is the data set, so I know how many days each person completed. And I'm saying I want this data set, but only the rows that have a count value of 21. So where it's people who have completed all 21 days. So I created that up here. There are 20 people. So you can see that the value is all 21. And I just took the first person. So the first ID was 105. And it's the same plot as above, but now where it asks for the data set to use, I am subsetting to just the rows for participant 105. So same data set, but where the ID number is only 105. And I can get rid of this color equals factor ID part here because there's only one person. So I don't need to distinguish between people with different colors. Okay, and voila, this is super cool. I love this. This makes me very happy and tells me that it was worth measuring curiosity from day to day. But it is a little misleading because the actual value of the curiosity variable was from 1 to 100. And here it is just going from 30 to about 70 something. And so if we really wanted to represent this data in a way that respects the original scale that it was on, we would change the y-axis from 1 to 100. And that's some nice homework for you all. So as you're kind of going through this script, see if you can change y-axis to go from 1 to 100. And I would suggest Google, literally if you Google change the scale of the y-axis ggplot, you will get 100 resources to do so. But if you have any issues with it, just shoot me an email and we'll make it happen. Okay. So this is great. What about their happiness? So doing the same plot for the same individual, but now we are also looking at happiness in addition to their curiosity. So there's an additional row where I'm doing geomLine to make a line. And I want to distinguish between curiosity and happiness by color. So curiosity is going to be red and happiness is going to be blue. And when I do that, I end up with this, which is kind of ridiculous that it works so well. So if the question is like the extent to which happiness and curiosity co-fluctuate, the fact that you can see it, like, you know, when remember red is curiosity, curiosity is low, happiness is low. When it's high, happiness is high. It's, you know, pretty nice association going on. But remember, this is just one person out of 78. Is this too good to be true? And so we're going to look at 107, who I think was like the second person. Yeah. So same plot, but now for a different person. And our beautiful association between happiness and curiosity goes away. But those are the breaks. I mean, there could be something still there, but it's certainly not as clean as it was for the other participant. And you can see, again, a reason for playing around with the y-axis. Here, this person is going from a little under 20 to 100, whereas the previous person is going from 30-ish to 90-ish for these two variables. Okay. So maybe I want some additional information in this plot. Maybe I want to know if curiosity is higher on days when people meet people they don't know, so when they interact with strangers. So there is a variable in the data set called interact stranger, because I'm very creative in my naming conventions. And we can just get a sense of this variable. Again, this is a binary variable now. They either interacted with a stranger or they didn't. So it makes more sense to me to do a table and get a sense of the number of instances in the entire data set where people did not interact with strangers, that's a 0, versus when they did. So typically, across the entire data set, there are more days where people didn't interact with strangers than days they did. All right. And now I want to add this information to the plot. So because it's a binary variable, it's either on or off. So I'm going to want the background just to be shaded from one day to the next in a way that tells me if it was a stranger day or a not stranger day. So I'm going back to the plot for 105. And pretty much everything is the same except for this new command called geomrect. So it's like making a rectangle. So I'm basically making a rectangle for each day. And the reason I have minus 0.5 and plus 0.5 is that it will instead of just kind of being on this like line, it's going to fill down to this line and up to this line. It will make sense when it gets plotted, but that's what the minus 5 and plus 5 means. And I want it to go from all the way up to the bottom of the plot, so from 0 all the way up to 100. And I want the color of the rectangle to reflect the interact stranger variable. This alpha controls how transparent it is. You don't want something like 0.8 would be less transparent, and that would make it harder to see these lines. 0.2 is high transparency-ish. You can play around with that number, which will let us see the rectangle, but it won't overwhelm the lines. So let's do that, and voila. So in this case, I find it useful to have the guides for this because it's telling you that pink is no stranger interaction and blue is a day of stranger interaction. And so you can see the minus 0.5 plus 0.5 thing, right? So it's like minus 0.5 plus 0.5, and that gives you a nice little rectangle for day 1. Same with day 2. Yeah, so this just gives you a sense of like how many days there were where a person interacted with a stranger versus when they didn't. And you might be interested in some kind of ordering stuff where, there's days where they go a couple of days without, stretches where they go a couple of days without meeting any strangers, and then a couple of stretches where they go a couple of days and they meet strangers every day, which might be interesting if you care about that stuff. Okay, and then the last thing we're going to do is we are going to do this for participant 107 instead of 105, and you get your beautiful plot. And note that by setting the min and max of the rectangle to 0 and 100, we're now across the entire scale. So you don't have to play around with the y-axis. All right, so this gives you a sense of how to read in your data, to start describing it, to start plotting it. And so for homework, due at our next class, I want you to go through this, and instead of happiness and curiosity, pick two other variables in the data set that are most interesting to you, and just swap the variables in and out where happiness and curiosity are. Some of the variables may not be made up of more than one item. That's totally fine. You just would have to then skip this step where you take the average of the two items to make a scale. So it should be relatively straightforward. If you run into any hiccups, let me know. And then in terms of the file that you then upload to Canvas, you can just upload the OR script that is annotated with the results. So you see, if you can put in annotations that are based on your data rather than the happiness and curiosity data, that's all I need. I'll be able to run it on my data to see what your plots look like. Feel free to be creative with the plots if you like. You can figure out how to change the default colors to make some works of art. All right, have a good week.